Welcome to the 43rd video in our series about Unix tools. In this video, I will show you how to compile with debugging information, how to set the optimization level, and how these changes affect the object files. But first, how can we automate the compile and link, since that is so tedious to type? So, we have to go back and look at our history and see what we had to type. And it's so far off the screen, it's gone. But if you remember, we had the whatidid.txt, which was limited to the kinds of commands we really had to type. So if we delete all the generated files, that's the executable, those are the object files, and we remove those, we're down to the 2C files and the header file. So how did we build that application? I'm going to use Nano and build a simple shell script that's going to build the application every time I need it. So I'll call it do it, and I'll put a .sh to let me know it's a shell script. Shell scripts always have to start with a hash bang, and we're going to run this with a default simple shell, a Bourne style shell. And what do we have to do? First, we need to remove hello and any object files. Then we need to gcc compile only hello.c to hello.o. We remember that. But at this point, you say, I know there's another C file. What's it called? I think it's helpers.c. And then I've completed compiling each C source file into an object file. Now we need to do the link, which says take hello.o and helpers.o and output the executable hello. And that is the sequence of commands required to build things. So let's save it into doit.sh, and remember, if we want to run anything, we have to set the permissions. So let's chmod, and we're going to say the user group and other, add the execute for doit.sh. And if we take a look again, we see doit.sh has the permissions. Let's try to run it. We don't see any output at all. Did it do anything? And if you look, yes, hello.o is created, helpers.o is created, hello is created, and if we run it, it worked. So we now have an automated system to rebuild anytime we want to rebuild. It doesn't output anything, but it does work. Good. That was the first thing I wanted to show you. The next thing is, how can I specify how much optimization I want? And it turns out there's a special -O switch to the compiler. And after the -O, you normally give a number. It's a computer system, so numbers start on 0, not 1. 0 means do not optimize. 1 is optimize a little bit. 2 is optimize for production. And 3 is go crazy, optimize anything at all possible, even if it's dangerous. From those choices, I think you know, we would like to have no optimization to see if we can change that printf in helpers.c so we really get printf and we don't get puts. Okay, where do I put that change? Well, at this point, everything's in the do it. And so we can add that flag, optimize not at all, or do not optimize. That's an O followed by a 0. And you need to put that on every GCC invocation, every time you run GCC. Save it. Let's run it. Make sure the program still works. And let's do that objdump XSD on helpers.o. And you can see it's still calling puts. We can't really control that. Look at these ugly colors. I don't know about you, but I find yellow or whatever this gold color is on a white background very hard to read. Very low contrast. If we put this on a projector, it would be almost invisible. I want to turn off the colors for objdump, but otherwise leave it alone. And if we look carefully, we go here and we search for color, and we can see, okay, we know that's the disassembler, and there is a disassembler color off choice. Fine. Let's add it. And we get black on white, high contrast, the way the Unix gods intended. All this colorization stuff is from the new generation of people, and it makes everything hard to read. Otherwise, it looks exactly the same, no change. We still have the puts, even though we recompiled, and you could say do it again just to be super safe. And we have to remember our SH. And yes, it's still puts, even though we asked for printf. It turns out, even when you say don't optimize, the GCC compiler still optimizes some. That's just the nature of that compiler. Okay, we've tried our best to disable optimization. What about adding some debug information? Yes, we can do that. And the way to add debug information is to add a -G. And -G says add the debugging information. And so we've added the debugging information when we create the objects and also when we do the link. If you forget this on the link, it will lose the optimization on some systems. So we've made the changes, save it, run it again. Let's take a look. It's a little bit larger. When we run it, it still works. The assembler dump looks exactly the same. But look at this. We've got a lot more information here. We've got more information here that we didn't have before. And it says, wait a minute. There's a debug info. It's compressed. And its contents have not been expanded. Well, I can't look at this compressed stuff and figure out anything. I want it expanded. So clearly, we're missing some option on objdump. So look for anything about compress. -Z, decompress sections before displaying their contents. Okay. Display debug information in the object file. Yeah, I want both of those. I want the -Z and I want the -G. Look at that. It's so much stuff, it doesn't even fit on the screen. So here is our list of sections. Here is the symbol table, and it says greet is in the text section. Put S, I don't know where it is, it's undefined in this file. Inside the text section, it shows the actual hex bytes. It shows the read-only data, which was our string, hello BUU. It shows some debug information, decompressed. We don't have that warning anymore. It isn't decoded. They don't tell us what it means yet. But we also get this debug string, this debug line string. And if we keep going, it actually decodes the debug info section after the assembly, and it shows you all this stuff. It's confusing. I don't have time to explain it, but this is called dwarf debugging information. But you can see it's got a lot of information. It tells you you're using C11, not C99, not C17, it's using C11. It knows the name of the file. It even knows the directory where it was when it was compiled. It knows types of things. Wow. And then it goes down here and tells you more. And you just start to have your head explode, because it seems like there's just too much information now. But don't give up. At least we can see everything that can be known, everything that can be shown is there. And once again, we've reached the end of our time for this video. Please come back next time and I'll show you how to run the debugger. But until then, thank you for listening.